Alright, now that we have a little bit better understanding what an HMI is, we're going to take a look at one example of an HMI, a few screens from a project I did in the past, and we're going to look under the hood of Factory Talk, get a behind the scenes view of what's going on, how the information is coming and going, and exactly what makes an HMI tick. Here we're looking at what an operator would see on a small 6-inch panel built into an enclosure on one water treatment system. This main menu offers 6 navigational buttons, including this alarms button on the top right. Clicking any one of these takes you to a different page of the menu, which we're going to look at here in a second. And down below you see some counts of regeneration cycles which have been run. And this is something that is only visible after you click an invisible button here and hold it for 20 seconds. So these aren't something that the customer ever sees, these regen counts. These are something only used for service personnel. So there are a lot of ways to build things into your HMIs that the operators might not even see or that are only used for engineers. But we'll get to that a little bit later on in this section. The overview screen of this project shows 3 vessels or tanks which are used for treating water. Each one of them has these red things covering the front, which are actually valves, and the color red indicates that they're closed. When they open, they turn green. You see this receiver tank to the left. Well, that blue level actually rises and falls based on the actual water level of the tank. Here on the bottom we have various displays showing inlet pressure, outlet pressure, pressure difference between the inlet and the outlet. In this project we use that differential to determine when these vessels are dirty and need to be backwashed. We have a well pump, we have a receiver pump, and we even show a time remaining on the current backwash cycle. And this indication only appears when the backwash is actually running. So this is a pretty smart HMI. We see these manual tags which also turn into automatic whenever the vessels are in automatic control or manual control. We have these labels below that say backwash and fast rinse. Those actually alternate through 5 different stages of backwash depending on if the vessel is in a backwash state and which state it's in. If it's not backwashing and those vessels are in normal operation, these labels disappear altogether. Clicking on any one of those vessels brings you to a separate page with a hidden button that gives the operator specific control of each one of those valves to force it on, force it off, or to leave it in automatic mode. So even though it's not called HOA, this is HOA control. We also have navigation on the bottom, which takes us either to filter A or filter B, this obviously being filter C. There's a setup menu which brings the operator into all of the more specific configurations such as alarm set points, times, temperatures, things like that. We also see here on the bottom that we have log in, log out, and this box on the bottom with all of the S's tells who is logged in once this HMI is actually online and running. And this log in and log out is used to protect certain functionality from unauthorized personnel. So that's something that we'll also get to a little bit later in this section when we're talking about permissions. And here's something that should look pretty familiar. For our backwash valve, which is labeled BV117 in this project, here's a basic handoff auto control for that valve, along with this green status indicator which toggles between off, auto, and hand. And this is a pretty standard alarm screen for a panel view HMI. This shows a history of what alarms have occurred and give familiar options to silence alarms and reset alarms, and we've talked about both of those in the alarms section of this course. This screen also gives the operator the option to clear the history and a navigation button to return to the main screen. So those are several screens of the HMI that we're going to be looking at. And now we're in the FactoryTalk View Studio HMI development environment, and we have open the actual HMI that we were just looking at. And now we're going to take a closer look at how information flows in and out of an HMI and how it's basically laid out inside of an HMI development environment. And in a later lecture in this section, we're going to actually be creating a small HMI so you can see the process of creating an HMI. The first thing in almost every HMI program, and that's Allen Bradley, Automation Direct, Maple Systems, or almost any other HMI development environment, is tags. The term tag refers to each and every data being read from a PLC or written to a PLC. As an example, let's look at a few tags within this project. We're looking inside of a folder here labeled Setup, and we have several tags. I'm going to go ahead and expand this menu out so you can see them. And we have one tag name here called Setup/Backwash Time. Now, backwash time as a description, and this is all contained in the HMI project, says that is the backwash time set point. So this is a set point that we're allowing the operator to configure, and that's going to determine how long our backwash cycle lasts. When we look up here through the tag setup parameters, aside from the name, we see that we at one time had to define this as an analog tag. Analog versus digital. We remember the difference that analog is something other than 1 and 0. This is larger numbers. We've set the description here, and it's allowing us to change that description if we want. We've set a minimum and maximum range in this HMI project of 0 to 100. So even though the PLC integer location can hold a much larger number, we don't want the operator putting in anything greater than 100. So we're limiting his options in the HMI so that if he tries to enter 200 or 1,000, it's going to kick back and say that there's an error, and the HMI won't write that information to the PLC. For data type, we have unsigned integer, and you see we have several options of exactly what type of data that this can be. In this case, if we look down in address, we see that this is stored to the shortcut micro, and this has an address of N7:4. And N7:4 should sound very familiar. It should sound a lot like a PLC address, and that's because this is writing to a Micrologix PLC, just like we've been programming in previous sections. And this is writing to an integer address N7:4. We also see under data source that we have type, device, or memory, and that's because we can actually read or write information from the HMI memory, not just an external device. But in this case, we're looking at tags from our actual PLC, so this is addressed to a device. And aside from our first tag, backwash time, in this list, you see we not only have analog, but we also have some digital tags. So let's go ahead and click into one of our digitals. This one is regen on DP-PB, and that is regen on differential pressure push button. And what this is a push button on the HMI. It allows the operator to determine whether a regeneration will occur on high differential pressure or not. So that's turning regen on DP as a function on or off. That might not make a lot of sense to you at this point. That's okay. We're not really talking about the process and operation of a water treatment system as much as we are the functionality of an HMI. So bear with me if maybe that description of the push button we're looking at doesn't make the most sense. Here we can see an example of type digital. And you remember under our analog type we had this minimum and maximum and scale and offset. These things don't pertain to digital because our maximum of a digital is always 1 and our minimum is always 0. We remember that was the whole idea of what digital is. So we don't need those options here. All we need to know is this a device tag or a local memory tag? And of course this is our device. Micro, which I'm going to show you where that micro comes from in just a moment. And here we have an address of B3:0/3. And I know that sounds familiar because that is a bit within our PLC. So each and every point of information, every integer, every float, every bit that we want to use in our HMI, whether we're reading that bit or writing that bit or integer or float, we have to define it as a tag. And the reason is, whenever we're referring to those things throughout the HMI development process, the HMI needs to know where to get that information or where to put that information into or out of a PLC. So where does this micro come from? Well, if we look in our navigation pane on the left, and we come down here to RS Links Enterprise, Communication Setup, we get this largely vacant window with device shortcuts in the top left and one single entry micro. What this allows us to do is add several different devices and to map each and every one of them to a different device on our industrial network. So if you remember in the RS Logix 500 environment, we have an RS Links window that pops up and shows us our network and shows us any available PLCs that we can connect to, download to, upload from, and go online with. Likewise, we have the same type of interface built into FactoryTalk, and this allows us to create these device shortcuts and associate them with a specific PLC. Right now we don't have any PLCs connected to this environment, but if we did, they would appear over here on the right, and we could assign two different PLCs to this single device shortcut, one for design time and one for actual runtime. So in this project, we don't have anything assigned for design time, but for runtime, we do have a PLC defined. And the difference between the two is design time is for when the programmer is sitting at his desk, creating logic, testing it, making sure everything communicates properly, and referring to tags on a non-operational system. Runtime is whenever the HMI is actually online with the PLC in its final configuration and ready to run in a real-world scenario. So anytime we see a tag referring to micro, we know that that means it's looking for this specific PLC, and then it's going into that PLC for its memory address of B303 or N72 or etc. So now that we know basically how data is referenced from our HMI to our PLC, let's jump into some of the displays or screens and see how the controls use those tags. So first, let's look at a screen that controls one of our filters. Here we have a screen that we already looked at. We saw a filter C valve control screen earlier. This is a filter A valve control screen. Other than the filter they control, these screens were exactly the same. And down here we see days until BW, which is backwash. This gives the operator a countdown of how many days are left in their operating cycle before this filter will automatically backwash itself based on time. And we see these 3 pound signs out to the right. These pound signs are a data point inside of our PLC, which is a running countdown of days. And when we open this tag up, we see that built into the text displayed on the screen, we also have this entry right here, and that looks a little intimidating, but when we actually double click it, we see what it really is. It's just a tag to filter1 \days until, and we know that we can look at that in our tags library, and that'll break down even further into a micro reference into our PLC and a specific integer location of N7 or N something else. And here we see that this integer is constricted to having only 3 digits, 0 decimal places, which obviously makes sense because it's an integer. And this fill left means if we have extra spaces that aren't used out of our 3 digits, then we will either fill those with zeros, spaces, or with nothing. So that's maybe a little technical at this point, but I'll go ahead and explain it since I mentioned it. We're giving this data point on our screen 3 digits, XXX. Well, suppose our actual value is only 1. Do we show a 1? Do we show space 1? Or do we show 001? In this case, we want it to look more natural, and we want it to resize itself automatically based on the number of digits in our value. So we went ahead and filled it with none. So what this display does then is says days until backwash, space, and then it references the tag filter1 days until, which will be a simple 1 or 2 or 5 or 10, and it'll say we have that many days left until a backwash. So next, let's look at one of these displays. This is called a multi-state indicator. We see that this has 3 different states, and those states can be increased all the way up to 2,000. I can't imagine having 2,000 different states for an indicator. That would take forever to set up. This one only has 3, and typically the ones that you build when you're programming will probably only have 2 to 5. And you see we have some configuration for the appearance of this display. We won't get into the specifics of all of that. We see that we have the states defined. Each one is a value of 0, a value of 2, a value of 1, or an error value, which is for any value that isn't specifically defined with a state. And for each one we have some customization of what the colors will look like, what the caption will be, the size of font. And this last tab shows us connections. And connections points to a tag. In this case, device status /011A_force_status. Now if we want to look at exactly what this device status 011A force status is pointing to in our PLC, we can click on tag and go into our device status folder. Let's expand this out so we can see the name 011A force status, right click and edit HMI tag, and it shows us right down here that we're looking into our MicroLogix shortcut that we set up on our communications, and we're looking for the integer location N34:21. So if we want to see what this value is doing and how it's calculating inside of the PLC, we know exactly where to go when we open up our PLC program in RSLogix. So back to our display, we see we have several other things going on, several other controls. I have a hidden button, which is this rectangle right here. And if I double click on that hidden button, I see that it's a go to display button, which takes the operator to the screen called 02 main graphic. So with this hidden button over our vessel, when this HMI program is running and the operator touches this vessel, it goes back to that overview screen which shows all 3 of the vessels side by side and the general status of the equipment. So let's move that out of the way, and we want to look at these valves for a second. So I right click on that valve, I'm going to Animation Color, and we have this interesting menu that pops up with a lot of different animation options. such as visibility, rotation, fill, and let's look at color because that's the one we're using here. You see, as an expression, we're tied directly to a tag, device status, BV, which is ball valve, 001A, A because this is on vessel A. And we have two different states here. We have state 0 and state 1, and a different fill color for each state. So if this tag brings us back a 1 from the PLC, then we're going to color this valve green. And if we pull a 0 from this tag in the PLC, then this valve is going to turn red. And that is what we're using to show the operator that this valve is either open or closed. It's either green or it's red. And that is basically how all of the displays and all of the inputs on an HMI screen are set up. And we're not going to go through every single instruction in this HMI development environment, but later on we will walk through setting a few of the more common controls up. And really, once you understand how to set up one or two of the controls in an HMI, the rest of them are pretty self-explanatory. They all have a simple behavior and they all associate with tags in our PLC. So once you can define a tag and once you can drop a control and put the tag into its reference, the rest is just a matter of creativity on the part of the programmer and deciding what controls to use and what information to work with. But that is the basic operation of an HMI, and we're going to get a little more in-depth in a couple of aspects of this in the following lectures. But for now, you should have a decent understanding of how truly simple an HMI really is. It's just tags defined to memory locations inside the PLC and simple controls laid out on a screen which reference those tags. There is usually no logic, no math, nothing else that a programmer has to worry about when developing an HMI other than making it look pretty and associating it to the correct tags. I'll see you next lecture.